So my name is Catherine Pennington. I am an engineering geologist and landslide specialist here at the British Geological Survey. I lead our coastal landslide observatory work, so I'm interested in monitoring on a local scale, and as well as that, I'm involved with our national scale landslide databasing here, and also global scale landslide monitoring, which is what I'm going to talk to you about now. So I'll just share my screen. Yes, so this is I'll just move that out. A real-time global landslide incident reporting tool that we've called the Global Landslide Detector, which uses social media and machine learning. This was is an interdisciplinary effort between landslide expertise here at the British Geological Survey, so that's me and Dr. Vanessa, computer scientists at the Qatari Computing Research Institute. So we have Ferda, Ofli, Mohammed Imran and Umair Qazi, and earthquake and social media specialists Rémy and Rémy Bossu and Julien Roch at the European Mediterranean Seismological Centre in France. So the context of this really begins with data latency, which is the time lag between a landslide happening and data becoming available for the response to that. So we know that satellites collect imagery, and when a disaster happens, the responding communities have to activate the disaster charter and then process the data. The speed at which this can happen depends on the satellite return path, route it takes, the image quality, and then how much time is taken for the processing. And this can be hindered due to cloud cover. So we know that landslides happen when there's rainfall and volcanoes. So we can have obviously cloud cover getting in the way there. And it's been estimated in the literature that this data latency time can be from several hours to several days. The impacts of some of these landslides are often not discovered until they've been reported through location-dependent frameworks. So that might be local government or charities coming in to respond to events, or it may be news media coverage or satellite data acquisition, which we've already mentioned. So talking about the way that landslides are reported, particularly in the news media, this reflects the range of physical and socio-economic contexts of wherever this is happening, and the impacts specifically with the damage and loss. This really varies globally quite a bit. It might be that the attention of the news media isn't uniformly distributed, so that it might be that there's some other higher profile news that's happening that changes the focus of the media, or it might be that they haven't quite got the facts right, or they can't actually physically get to the locations. So some other researchers have published that globally quantifying landslide hazards and their impacts is an underestimation, and that was David Petley in his well-known paper. And then this underestimation then will feed through to landslide databases, especially where landslide susceptibility mapping doesn't already exist. Landslide databases, be they national, regional, or smaller scale, have been established in many countries around the world, but they're not consistent in how they're applied or the data that they collect. So they might be used for science research, they might be used for landslide susceptibility mapping, disaster risk reduction or planning, forecasting, and then, of course, documenting impacts of climate change. And the databases also vary depending on the wealth and the politics and the governance of within the host country, or the level of education that will vary across countries depending on who is collecting the data. It might be driven by insurance processes, or it might be driven about landslide strategies of the host nation, but also the availability of institutions that are willing and able to maintain them, because it's a long-term investment. Which brings me nicely to social media. So social media, as we all know, is a rich source of information about humans specifically. So this includes text and videos, photographs, it includes timestamps of when things have happened, but also potentially coordinates. And these are now called social sensors. So last year, 3.78 billion social media users existed in the world. And the data are really noisy. It's full of pictures of people's cats and their dinner and all sorts of really rubbish, but that's important to people. But that means that it's difficult to extract relevant information in a timely way as well. However, the data are in really large quantities and they're in near real time, and they can be at spatial densities exceeding conventional physical sensor networks. And perceptions are changing about this. So what was 10 years ago considered as very unreliable data are now being seen slightly differently, and acquiring disaster data through this is really gathering pace in the last decade especially. So the work we've done, we are hoping it might be able to fill in a real-time time gap between events happening on the ground and sort of more reliable data happening coming in from satellites. However, I've underlined the word biases here because it's important that the limitations of this kind of tool are really understood before they're used. So we're hoping that this can be used to complement other data sources and workflows, plus other areas of landslides research, such as landslide databasing. So here at BGS, we've been collecting landslides information about the UK landslides for 10 years now on a daily basis. And if you're not already following us on Twitter, please do go ahead. We're at BGS Landslides. And what we found is that this allows us to see landslides that have newly happened, landslides as they're happening, because of course everybody now has smartphones, so they're taking photographs of things happening. We get information about what causes landslides, about how they've been remediated much later on. So the context of a landslide isn't just now as it happens, but the story continues through to remediation sometimes. But impacts especially. So this is an example, a famous road in Scotland that is affected by debris flows repeatedly and is often closed. The impact of closing that road is a 57-mile detour, which obviously has impacts for the economy, but also on things like people getting to hospital. So it's quite, this source of information is really useful for that. And it also allows us to have eyes on the ground in different ways, in lots of different places. So lots of people are now flying drones, so we're getting aerial shots of landslides or videos. So that's been also very useful. As I said, we've done this for 10 years, and this graph sort of nicely shows the impact that social media data have had on our data collection on a daily basis. And you can see when we've had wet winters in the UK. But before that, it was much less data coming in. We were relying on newspapers, sometimes physical paper versions as well. So it was a much slower process. So back to the global landslide detector. So the aims of the work were to train a computer model to identify landslide features in photographs, which we then applied to social media to extract and locate landslides or landslide photographs in real time. So to do this, we had to think about it slightly differently. So we're not physically able to obviously go to the landslide. We wouldn't assess the landslide. We can't assess the landslide in a way we ordinarily would as geologists. So we had to develop a new methodology for teaching the computer model how to recognize landslides. So we had to assume that there was no previous understanding of the landslide or any kind of context, that we only had one photograph for each event, that the landslides needed to be contemporary. So that means that if you have a heavily vegetated landslide, that that might be missed, for example, because we needed the model to be, in this iteration, to be able to recognise zones of depletion, so where material has come from and where it has been deposited, so where it's gone from and moved to. The landslide needed to be a major component of the image, and we had to ask ourselves, when we had a case where we weren't quite sure, would the end user basically be bothered, or would they mind if this image were to appear as a landslide or not? The model also can't currently discriminate scale, so we might have a really zoomed in grains of sand would be treated in a similar way to a larger scale mass movement. However, we know that different techniques, so image segmentation techniques, for example, is something that we could do in future iterations of the model. So training the model, we've used, as far as we know, one of the largest data sets for training for this kind of thing for landslides that's been done. So 3 geoscientists, 2 at BGS and 1 at EMSC, we independently verified over 11,500 landslide images, or not just landslides, but images. And these images were taken from Twitter, Google, and also here at BGS we have a photograph archive. And this is an example, excuse me, of how it works. So we basically would go, yes, 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 yes. Can't see really a landslide in that picture. Yes, you can in this one. No, no, no. So it was quite a task, I can tell you. We also couldn't include images like cartoons, even though that is a landslide, but that wouldn't be included. But this is the sort of thing that we had in the data set, so it was quite varied. So the live model works by these little birds here represent tweets spinning around in on the internet, and those are sucked in to the collector tool that uses keywords that we've made a list of currently of landslide terminology, currently in 32 languages, but we definitely need this to expand. And each tweet had to have one of those keywords and a photograph associated with it. It then goes into the tagging process, which then divides the images into whether it is a landslide or not a landslide. And this month, we're at 3.8 million images that we've extracted so far. So this is what you see when you go to the web page. Anybody can go and look at it at the moment. You can get to it on this URL at the top here, or just Google Global Landslide Detector. You can filter on the date and where it's come from and who's tweeted it, whether it's organisations or individuals or everything. And you'll be presented with it uses an API to basically look at Twitter, and it will show you the tweets that have landslides in the photographs that have been associated with the keywords. And we're looking for feedback on this. There is a feedback form up here. There's links to papers that we've published and a how to use it guide. So as well as presenting it this way, we've also plotted where we think these are on a map. So this is a really difficult computer science task and is definitely something that I do not know much about. However, I will attempt to tell you about it. So this was carried out by the Qatari Computer Research Institute colleagues. And essentially what they're doing is taking the text and then using the information within that to locate the landslide, because we found that that's more reliable than using geotagging, or if someone's typed in a location, because you can add locations manually within tweets. However, if there's no information in the tweet and there is shared location information, we'll use that. And that essentially uses a lookup dictionary and is based on some improved methodology that is published in this paper here. There's obviously some ethics around locating people, locating tweets. So we have intentionally downgraded the location because lots of people will tweet from home, and we don't want to be able to have somebody's personal information. And here in the UK, we're bound by law to do that. So the system's been running since February 2020, and we've collected more than 54 million tweets and 15 million image URLs, of which just under 4 million have been deemed to be unique and have been downloaded for further analysis. Of those, 46,500 have been designated as landslides as of this month. So that is about 1% of all of the images that are collected. So it really does highlight the nature of the problem, how challenging it is, and just how noisy social media data are. So there has been some verification done. We randomly sampled 3,600 images, and the validation scores, the verification scores have come out as acceptable so far for what we would expect for this sort of model. These heat maps I've included just because they're quite nice, because they show you where the computer is looking to focus its attention to decide where it's a landslide. So I mentioned earlier about biases and the limitations. We feel strongly that these limitations are understood by anybody that's using this. So it is essential that everybody understands that this system does not replace expert survey, and the data come from anybody that uses social media. Each photograph is analysed in isolation. The model does not discriminate landslide types. It's purely looking at where material has moved from one place to another. And it excludes where landslide debris has been removed, which therefore excludes many coastal landslides, some fluvial landslides, or those that have been remediated, unless obviously the photograph's been taken before that's happened. It also aims to show contemporary landslides. There has to be a clear representation of the landslide as a major component of the image. I've already mentioned about scale as being something that we need to improve in future iterations. And this model is definitely not intended to be used in isolation during a disaster scenario, but it could complement existing workflows about finding real-time information quickly. However, things like mobile coverage, not everybody uses Twitter, for example. How widespread is that use of social media? And also population density will skew that data to where there's more people tweeting about things. The locational accuracy of the landslides on the map is automated and is still a work in progress. Our next steps that we want to take are stakeholder engagement, really, and finding out about what's the where is this, who could use this, and that's why we're asking people to feedback about it. So we're considering about workshops, we're looking for collaborations for all areas, about whether it be landslide databasing, research, or disaster response. We want to improve the keywords. We know we're missing key languages. We're also looking for both the technical words, but also cultural words. So because the tweets are coming from anybody, are there words within your language that mean landslide that we may not use in a scientific sense that we can include in this? We want to look to include other social media platforms, and also improving the map, although with ethical considerations around that. And obviously funding is always on everybody's agenda. So we're looking for how to go ahead with that as well. So yes, thank you. And please do provide some feedback about the tool through the form, or you can contact me directly. And this is a link at the bottom here to the paper.